Chris Zeleny. Welcome to In the Element. Join me as we get insights from key individuals within the Dicker Data and HPE ecosystems. My name is Chris Zeleny. I'm the pre-sales manager here at Dicker Data, and I'm also one of our HPE solution architects. Now, the goal today, we're going to be going over one of my favorite platforms in the HPE portfolio, specifically the MSA, or the Modular Storage Array. Currently up to the 6th generation, which was released in 2020. Now, the MSA has been part of the HPE portfolio dating back to 2008, where we first introduced the P2000. Since then, lots of innovation, there's lots of new things that have come to market, drives have increased, controllers have gotten faster. We're going to go through a couple of those things, but first we should have a look at what the portfolio actually looks like today and where each of the arrays are positioned. Now, the portfolio is very small. There's a couple of different ways to look at it, but fundamentally there's 3 different arrays. We start at the 1060, which is what we're going to call the entry-level array. We then jump to the 2060. Now, that jump, what we get is more scalability in terms of capacity, more performance, and also more host ports. The third platform in the portfolio is the MSA 2062. It is identical to the 2060 with 2 exceptions. Those exceptions, it comes with 2 1.92 terabyte SSDs, and it also comes with the Advanced Data Services license as standard. That Advanced Data Services license, we can apply it to the 1060 or the 2060, but it comes packaged in the 2062. Now, what do we do with those 1.92 terabytes? Well, there's 2 things. We can either use them as extensions of the read cache, or they can be the start of a performance tier within your pool of storage. In terms of protocol support, now there's some intricacies here that we need to be aware of. So the 1060 supports 16 gig fiber channel, 12 gig SAS, and 1 or 10 gig iSCSI over base T. So we're talking RJ45 connector. The 2060 and the 2062 support everything that I've just mentioned, as well as 10 gig iSCSI over fiber, so SFP modules. Interestingly enough, depending on when this video is released, it's also going to support 25 gig as well. As for the differences between the 1060 and the 2060, what I mentioned was performance and scalability and host ports. In terms of scalability, the 1060, what we can do, we can attach up to 3 disk shelves to the back of it. So these can either be large form factor or small form factor. If you want to max this out in terms of capacity, you're looking at roughly 900 terabytes raw. The 2060, this increases it to 9 expansion shelves. Once again, you want to max it out, you're looking at about 2.4 petabytes worth of storage. The other metric we gave there was performance. So if we just look at IOPS, 8K random reads, the 1060 can support about 150,000 IOPS. Okay, the 2060 will jump up to about 400,000. Now, what does the Advanced Data Services license do? 3 things. The first thing, it enables performance tiering. So what I'm referring to here is you've got a disk group made of SSDs, which are going to be your most performant tier, and a disk group made up of 10K or 15K SAS drives, less performant. The automated tiering engine is going to distribute pages based on how hot and how cold the data is. The second thing it does, it increases the array's snapshot capabilities from 64 to 512. The third thing it does, it enables replication on the array, which is what we refer to as snap replication or snapshot-based replication. Now, this is asynchronous replication, and it can be either fiber channel or iSCSI. Now, we're going to speak about the architecture of the array, and this differs from some of the other platforms in the HPE portfolio. So in the back of the array, you've got your 2 controllers. Now, these are active-active controllers, means that they are both operational at the same time. What it doesn't mean is that a volume is not going to be striped across the controllers, okay? A volume is only ever going to reside under one controller. In a failover situation, the remaining controller will take full ownership of that volume, and it'll be a seamless transition. We've mentioned this concept of 2 controllers. So what happens with the MSA, a controller is going to support a pool being a pool of storage. Within that pool of storage, you've got your disk groups and your volumes that live within. This concept of pools hasn't always been the case with MSA. Back before the MSA 2040, The storage technology was referred to as linear storage. Now that was your traditional, the way a RAID group traditionally works, where you've got a set of disks, you provision it in a RAID level, and you're going to have your data striped across the disk. RAID works really well to increase capacity and increase performance because we've got multiple spindles contributing to the workload. The downfall of traditional RAID is that your volume is confined to those parameters in terms of capacity and performance. What MSA introduced during the 2040 generation was this concept of virtual storage. Now, virtualized storage, it enabled wide striping across multiple disk groups within that pool supported by that controller. So once again, it's that concept of more spindles contributing to the workload. So wide striping across multiple disk groups. The other thing that it introduced was the concept of striping up and down the tiers. So what is the benefit of performance tiering? We know the characteristics of a hard drive. You've got your rotating platter and you've got your seek head as well. This works very well in sequential situations where you've got sequential reads or sequential writes. As soon as we start looking at random reads or random writes, it introduces a lot of seek time latency. What the MSA does very effectively is it's got an automated tiering engine that redirects reads and writes based on the characteristics of the read and write. So for example, if we've got some random writes coming in, they would be better serviced on SSDs rather than spinning media. Now on the read section, every 5 seconds, the MSA analyzes all of the pages in the pool and it redistributes them according to how hot and how cold they are. So hot pages will be moved to your fastest tier, which would be SSDs. Cold pages are going to be moved down to your 10K SAS or even your 7.2K SAS as well. All of this works automatically in the background. What we're trying to achieve here is SSD-like performance for, I guess, the pages that require that performance or the volumes that require that performance. There's no tuning necessary. MSA does all this by itself. So in terms of RAID levels, the MSA supports RAID 0, that'd be for your read cache, RAID 1, RAID 5, RAID 6, RAID 10. The 6th generation 2060 introduced another RAID level, referred to as MSA DP+. Fundamentally, it's a dual parity disk group, but it also has 2 disks worth of capacity as built-in spares. There's a lot of benefits using MSA DP+, but first I need to say that the minimum hard drive requirement is 12, and it can go all the way up to 128. Okay, so size alone, this is going to be much bigger than your regular RAID 5 or RAID 6. You can have a much bigger disk group. Now, the other benefits of MSA DP+, as I said, it's got built-in spares, so there's no worrying about not having spares provided for your disk group. That's all taken care for you. Rebuilding a spare is also much quicker. So when you look at rebuilding a spare drive in a traditional RAID group, your bottleneck becomes that single drive because we're trying to rebuild all of that data into a single drive. If you remember, I said MSA DP+ has spare drive capacity built into the disk group. That means it's distributed across the disks. So no longer do we have a single bottleneck. Those reads are going to be rebuilt to all of the spare space across the disk group. Now, the other benefit is in a traditional disk group, to expand it, well, there really is no concept of expanding a disk group. We can add another disk group that adds storage to the pool. MSA DP+, we can incrementally add disks to the disk group as we grow, and that disk group will grow organically. Some of the additional storage features and functionalities that the MSA supports. Encryption is a hot topic at the moment. We know about all the hacking and whatever else is going on in the world. The MSA does support encryption. It is an array level function, meaning you don't just apply it to a pool or to a volume. The whole array has to support encryption. It's going to be turned on. The way we do that is by purchasing encrypted drives. Now, food for thought here, if you're going to start with an MSA 2062, which comes with the 2 by 1.92 terabyte SSDs, these are not encrypted. So in order to encrypt an MSA 2062, we need to remove those and start with encrypted drives. Not the most economical way to do it, so it's just worth considering if you want to go down the encrypted path. The array also supports snapshots, which we all know they're a brilliant way to roll back to your data at an existing point in time. However, if we apply the Advanced Data Services license, we can support up to 512 snapshots across the array. And the third thing is replication. So now we're looking at site level availability. Let's just say your production site was to go down and we've got a recovery site that we can boot up it again. The MSA does support asynchronous replication, and this can be either over Fibre Channel or via iSCSI. Now, in terms of management, each of the controllers hosts what we refer to as the storage management utility, which is your user interface on how we administer and provision and manage the array. Now, this is all out-of-bound management. It's got no interference with the storage traffic whatsoever. And you can access it via HTTPS or the CLI. In line with trying to simplify IT operations, what HP has come up with is the out-of-box experience. So as you assemble the array, turn it on, you're going to be greeted with the out-of-box experience. It is a follow the bouncing ball type scenario that's going to go through array initialization, storage provisioning, and then also exporting your volumes and LUNs out to hosts. It'll take you through the whole process step by step. And this leads into the big question of InfoSight. Now, does the MSA support InfoSight? Not today. What we do have is the MSA Health Check, which is a step towards that automation, hands-off approach to managing the array. So what is the MSA Health Check? Well, it's a zero-cost, no-subscription reporting tool specific to the MSA that does not require a support contract to use. It interrogates your MSA for signs of non-compliance. Once you upload the MSA log files, you'll get an automatically generated report on 12 best practices across different parameters and different metrics. It also provides support and guidance on how to rectify these parameters. The other thing it does, it speeds up your customer service experience with Pointnext because Pointnext actually have access to these log files as well. What are some of these parameters that it checks against? Well, firmware, component health checks, volume mapping, drive sparing, and things of that nature. The other interesting thing about the MSA Health Check, whilst it was released for the 6th generation MSA, we can actually use the functionality all the way back to a P2000 Gen 3 array. So that brings us to the end of the video. Hopefully it wasn't too technical, but I also hope that we all learned a bit more about, I guess, what the MSA portfolio looks like, how it works, and where we can position it. So special thanks to Benjamin Smith, who's provided all the animations and slides throughout. If you do have any opportunities or any questions, please reach out to our sales team, who will put you in contact with our pre-sales engineers, who will help you configure and get the most out of the MSA.